I'm going to try to help build some videos here to see if I can help us through the technology. So this is part of the homework for this week. And I'm going to talk about how to use the tables for the t-distribution to find our t-values. So if you click on this blue icon here, it will bring up our table for the t-distributions. Remember, the t is very similar to the z. The biggest difference is we use the t when we do not know the population standard deviation, and we have to use the sample standard deviation. As you can see by our picture here, the area is always in the right tail. So when we find these probabilities, we're only looking in the right tail. So how do we read this table? So I'm going to bring it down a little bit so we can see my problem. So for the first problem, it says find the t-value such that the area in the right tail is 0.01. That is our probability of being down this low in the tail with 9 degrees of freedom. Remember, if they don't give us degrees of freedom, all degrees of freedom is your sample size, n, minus 1. So in this case, they gave it to us. So the first thing we'll do is we'll find our probability, or area in the tail, that corresponds to this number. So 0.01, or sorry, 1%. So I come down here in the table, and right here you can see where my mouse is, 0.01. Now, I will scroll down on the table till I see degrees of freedom over here on the left, and there is 9. And then I just line up the column and the row. So follow 9 over, and I find 1% or 0.01, and my t-value is 2.821. All right, so that's how we use the t-table. Next, I want to show a little bit how to use Excel to find our z alpha over 2. I'll go back to question 1. Bring up an Excel. So Excel is very useful. I prefer it over StatCrunch. Right now, I'm more leaning for StatCrunch for you all because you're learning the new material. And StatCrunch may be a little bit easier if you haven't used Excel. But Excel would probably be something you would use outside of the classroom because typically we don't use StatCrunch. So the way Excel works is, many of you probably used it for tables and graphs and all that stuff. But it does also have built-in calculations or functions. And how we call those is by putting equals in an empty cell. And then what I always tell my students is you just start typing what you want to do. So in this case, the z alpha over 2 is the standard normal distribution. And basically because we know the probability or the area under the curve we want, and we want to find the corresponding event to that, it's basically called an inverse function. So I will type in, and you'll find norm's inverse with an s. Because we're doing z, we want the one with the s. You can see there's also a norm inverse. We do not want that one. We want the norms with the s inverse because we're dealing with the z table. All right, and now it wants a probability. Well, in Excel was built the same way the z table was. So we have to manipulate Excel a little bit to help us find our critical value z alpha over 2 for confidence intervals. So we will first put in the number of our confidence interval. And since we're doing, in this example, a 95% level of confidence, I will take that percentage and turn it into a decimal, so 0.94. And then I have to add in my z alpha over 2. So I'll put a plus sign in here, and now we got to find alpha. Remember, all alpha is 1 minus our confidence interval. So I know it's 1 minus 0.94, which is 0.06, and that's alpha. However, we need to find alpha over 2 because we're building confidence intervals. We have a left and a right limit, so we take our alpha and we split it in half. So all I have to do is put divided 2, and enter. You see I get 1.88, rounded to 2 decimal places, which is the correct answer. I'll try to, like I said, build more of these as we get more into the technology and see if they can help. And I'll also try to post some YouTube videos for StatCrunch, or I'll create my own. Please let me know if these videos are helpful or not, though. I hope everyone has a good week, and I'll see you online. Is that not recording?